Good day, ladies and gentlemen. We are looking at another problem on Venn diagrams. So the question says, in a class of 80 students, 45 do mathematics, 55 do English, 15 do neither of the two subjects, and the X do both subjects. So the one you to calculate the value of X. And then after that, you present the information on the Venn diagram. Then you calculate the following probabilities. So let's start with problem 1. To calculate X, unfortunately, we have to start by representing the information in a Venn diagram that involves X to help us calculate the value of X. So the Venn diagrams always start with a rectangle. A rectangle represents the sample space. So in my Venn diagram, for me to put it, I must figure out whether there's something referring to both. So the fact that there is X who do both, which we don't know what is X, we need to draw a Venn diagram from mutually inclusive event. When there are both, it means there are students who are doing English and doing math, so the two events can happen together at the same time. So that is mutually inclusive. So it means in our rectangle, I'm supposed to get two ovals that overlap one another. So those are my two ovals. I will give them names. Those who do mathematics, we are told they are 45. So I will present mathematics by capital M. And those who do English are 55. I will present it by capital E. So whenever you are completing a Venn diagram, guys, you always have to start from the center with those who are doing both. In this situation, we are told that the students who do both subjects are X. So we don't have a choice but to put an X there. So that's where you start completing a Venn diagram. So we all know that in a Venn diagram, the portion at the center is for both. Then if we talk about maths, which is M, is the whole cycle. Then this is maths only. English is the whole cycle. Then this is English only. Then those who are doing none of the two subjects, they go out of the two cycles. So you start completing the Venn diagram from both. Then I can now start moving out. I need to check how many are doing mathematics. So we know that those who are doing mathematics are 45, but those 45 already include those who are doing both, which is X. So if I need those who do mathematics only, I will take 45 minus X. So if I were to add up everything in the circle M, you see that negative X and positive X will cancel one another. So that takes me now to those who do math only, to the 45 minus X. So we're going to do the same thing for English. Those who do English in total are 55. So English is the whole cycle for E, which already include X for those who do both. So those who do English only are 55 minus X. So that is how we are going through it. And finally, we are told that there are 15 students who are doing none of the subjects. When they say do neither of the two subjects, it means there are 15. So if you're not doing any of the two subjects, English or math, you must be out of these two cycles. So I've got 15 there. So from this Venn diagram, I can now solve for X. So I must not forget that there are a total of 80 students in that class. So that therefore means in this, our sample space, which is represented by the rectangle, if I add everything there, I must get to 80. So if I'm adding everything, that means those who do math only, both English only, and those who do none of the two subjects, I must get 80. So I'm going to that. So I'll take 45 minus X, then plus X plus 55 minus X plus 15. That must give me 80. So here, negative X will take care of negative X or positive X. So I'm left with 45 plus 15 is 60. 60 plus 55, that should be giving me 115, I guess. 55 plus 60, that's 115. So I get 115 minus X is equal to 80. So I can see that X will go there, 80 will go there. That will tell me my value of X to be 115 minus 80. So if you subtract 80 from there, you see that X is actually equal to 35. So that is how you get your X. So if you have this kind of problems that are talking about X, or they don't give you those who do both, and you are told that there's a possibility of some doing both, you are free to call it X, then you put your Venn diagram like that, then you solve for X before you will be able now to present your information in a Venn diagram that can be used to do probabilities. So we have succeeded to get X as 35, we can now present the information on a Venn diagram. So if I go back to my Venn diagram, I'm just copying the same Venn diagram up there, and in that Venn diagram I will place every X I see by 35. So my problem now looks like this. I've got my M there, my E there, my X is 35, so I put my 35 there. Then if I get 45 minus 35 for those who do mathematics only, it gives me a 10. 55 minus 35 will give me a 20. Then those who do not offer mathematics or English, 15 of them. So if you look at the whole story in there, you see that if you add everything, they will expect it to be 80. If you take 35 plus 55, 35 plus 15 is 50, 60, 80. So our Venn diagram is now ready for calculations. So we can now go through it and do our calculations. So Roman 3 says, what is the probability that a student choosing at random does mathematics only? So if you go to Roman 3a, the probability of M only, we are simply trying to figure out whether can you pick the portion called M only. So mathematics only is the portion with 10 students. So mathematics means the whole cycle, which has 45, as you can see. 10 plus 15 is 45, just like it was given. But if you're interested in mathematics only, it's 10 students. So we've got 10 out of 80. So the probability of doing math only is 1 over 8. It's the same thing like they would have asked you, what is the probability of selecting a student who does English only? You say English will be 55, but English only will be 20 out of the total population. So if I just choose to do that here, you see that the probability of English only, or targeting the portion called English only, which is 20 on 80, which will give us 1 over 4, if ever they ask you something like that. So that is it. You can then do our B. Our B says, what is the probability that a student choosing at random does not, the keyword is there, not do both subject. So you need the probability that you do not do both subjects. So we have just finished calculating our X, which was in the position of those who do both subjects. So if you do not do both subjects, it's very simple. I can just go here and close the portion for both subjects. If I close it, you will then see those who are not doing both subjects. There are 10 doing mathematics only, 20 doing English only, and 15 doing none of the two subjects. So 10 plus 20 is 30, 30 plus 15 is 45. So that's how I can see the probability of those who do not do both subjects. So I can see the probability of not offering both subjects, of how do I put it, both subjects will be math and English. So if you are not doing both subjects, you just put a bar there. That's the short mathematical way of writing it. Each time you put a bar in probabilities, it's referring to the not. So if you are doing both subjects, it means you are doing math and English. If you are not doing both, then math and English with a bar. So if I know how to read it from my Venn diagram, that's how simple it is. I can simply close the portion for both, which I'm closing the 35, then I calculate the rest. I see that I'm having 10 plus 20 is 30, plus 15 is 45 over 8. Or, if you want to use the idea of complementary event, as we all know that the probability of doing math and English plus the probability of not doing math and English should always give me 1. So, those who do both subject, which is math and English, we already see that those take 35 over 80 plus those who do not offer both. You can also choose to use the word both instead of writing much of English like that. You go to 1, then from there, if you take that side, you see that the probability of those who do not offer both math and English is 1 minus 35 over 80, which will still give us 45 over 80. So that can be another option of doing that. Then finally, we want to do Roman 4. It says, are the events, mathematics and English, independent? Do a calculation correct to 2 decimal places to justify your answer. So for math level 4 students, the formula for independence is formula number 29 on your formula sheet. So if I want to test whether the 2 events are independent, I'll be checking whether the probability of M and E is it the same thing as the probability of M multiplied by the probability of E, which is English. So if I start with the probability of M and E, it means I'm looking for the probability of those who offer both subjects, which is very easy to read. And in our Venn diagram, you see it is there at the center of our Venn diagram to be 35 out of 80. So since we did it correct to 2 decimal places, we'll just take 35 divided by 80. So that 2 decimal places is 0.44. Then I've calculated the left-hand side of the formula for independence. Then I'll go to the right-hand side. The right-hand side requires me to take the probability of M multiplied by the probability of E. So the probability of M means I check everything in the circle M. Those who do mathematics are 45. It was actually given to us. So it's 45 out of 80 multiplied by those who do English. You see it will be 55 as it was given to us. So we get 55 out of 80. Then I will calculate that correct to 2 decimal places and see what it gives me. So 45 on 80, I'm multiplying by 55 on 80. So that gives me 0.39. So it gives me 0.39. So if you compare the 2 answers, you can clearly see that the 2 answers are not the same. So your conclusion will be that the event math and English are not independent. So that's it. The event math and English are not independent. So if those 2 answers were the same, confirming that, then we'll be saying the 2 events are independent. So guys, this is just how easy Venn diagrams can be. So my advice is that you must know how to master the different portions of your Venn diagram. Once you know how to understand the different portions of your Venn diagram, you are sorted. You see, this is math, where there is 10 is math only, where there is 35 is math and English, where there is 20 is English only, but this is English, the whole cycle. Then out of that, then you have those who do not do both. So if they ask you any question on Venn diagrams, as long as you know the portions of the Venn diagrams, you always get it right. They can even ask a simple question like the probability of those who do not offer math only. Let's just add that one as our last question. We are saying what is the probability that the student choosing a random does not do math only. So if you don't know the portion called math only, it's a problem. So the fact that they say does not means if I know the portion called math only, if I want to see those who do not do math only, I just cover that. If I cover those who do math only, I'll see those who do not offer math only. You see everything. So a student who doesn't understand the portions of the Venn diagram will struggle with this kind of question of checking the probability of those who do not do math only. So I need to know the portion called math only, but that is the portion where there's 10. So if I close it up, I'll see those who do not offer mathematics only. So it will be 55 plus 15, that gives us 50 plus, that is plus 20 is 70. So if I were to say I'm doing Roman 5, probability of those who do not do maths only, so maths only, it's written like that. If you don't offer it, I just put a bar on it. That's the simple mathematical way of writing it. I'm looking for the probability of those who do not offer maths only. As I've shown you, if I know the portion called mathematics only, if I close it up, I'll see the rest that do not offer mathematics only. So the rest will be 70 over 80, and that is 7 over 80. So that is the story of the Venn diagram, guys. I hope that is helpful. Thank you very much.